an adventure, an absolute adventure. There we go. Hey. All right. I'm gonna keep this over here. Alex, you should pay attention to this. And if anything starts, if you start seeing dropped frames, that's how you know that everything is dying, and we should like panic. Because that's how prior streams we dropped like every minute for every frame. So should be good. All right. Lapel mic. Put it on. Maybe. Yeah, I don't know. I'll go sit down. I kind of want to just. Let's try it. Okay, that should be. I can just hold it. That's true. That works.
Okay. Testing. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. I'll just be saying that for a minute. Testing.
No, it's... That's...
Actually pretty good.
Yeah, that's probably okay. That's all right. We'll work with that. It's a tiny bit muffled.
Yeah. It's kind of just my voice though. Yeah. All right. Move these back to that slideshow. Everything's good. Thanks. There we go. All right, this is Multiplayer Netcode and Games. I'll be presenting to you today. I'm William Chen, and I've been, welcome. So I'm William Chen. I've been programming for around 5 years. The first time I programmed in with netcode and multiplayer was around like 2 years ago, and I've been messing around it ever since. So I'll go to the next slide. Today's agenda, we'll be talking about what is networking and how to get started, choosing a networking library, because choosing a networking library can pretty drastically impact how you work. And using a networking library, I'll be focusing on more concepts than the actual code itself. So I won't be focusing on Unity specific or Unreal specific or Godot specific code, but I'll mention those once in a while so you guys can see how those look in the actual engine. And then I have some references and additional resources. And networking is vast, so you always want to keep reading and researching and trying things out, because that's the best way to learn. So what is networking? It lets you create multiplayer games that are played over the internet. And I say played over the internet because it's a distinction between like couch co-op, which is like if you have like 3 controllers, people playing on a couch. That's more of a local thing than an internet thing. And some examples of network games that are commonly known is Minecraft, Overwatch, and Among Us. So all of these are pretty different in how they work, but they also adhere to the same principles of networking that all network games have to adhere to. So some of the challenges of networking are that you have multiple separate computers. That means that you have to connect the computers together. Any message sent between the computers will have a delay. So if you send a message from one computer to the second, it might take like 200 milliseconds, which is like on the higher end, but like you can expect like around 20, 50 milliseconds, and that's still slower than instant, which is what we're used to. Reliability, networking is like kind of like trying to throw rocks at someone and expecting that they catch it every single time. Except they don't catch it every single time, so you have to be careful with how you send your data. Security, you have multiple computers, if one of the players tries to cheat, that will be an issue for the other players, and it will ruin the game for everyone. And security is a thing that's pretty hard to do fully, but there's also like some security measures that in place that are fairly easy to implement, and I'll talk about that as well. Bandwidth is also important. Usually it's more of an optimization, but sometimes it's pretty obvious where you can like make it more optimized and send less data. And the issue of all of these challenges is that they all add complexity. So I'll be telling you, so in this presentation, I'll be focusing on the easiest route instead of like the more like hard route. So the focus of this presentation will be teaching you how to like make a actual game that's able to be put on the market as like a smaller team. And if you compare that to like a bigger game like Overwatch, Overwatch has a lot of security. It's really sensitive to latency. If you shoot at someone and it doesn't like register, you'll be very, very annoyed as a player. And those are things that you really can't afford to like implement as a smaller developer. So getting started. So what game are we making? And choosing a library and working with that library. And we'll use Among Us as an example because it is well known and it's relatively simple. So has anyone not heard of Among Us? I take it. Yeah. Okay, so what game are you making? So we'll find a library that suits your needs. Some example considerations for a harder game to implement will be like, is your game competitive? If it is competitive, it'll be harder to implement. If cheating has long-term consequences and you want to mitigate cheating, it is also harder to implement. What genre is it? FPS games, first-person shooter. RTS is real-time strategy, fighting, turn-based, etc. All of these genres have different ways of implementing networking, and it's fairly good to like, before you try to make a network game in that genre, to like research how it is implemented and what the unique challenges it has. Realistic physics. Physics is really hard to do properly with networking. So if you have physics, you usually simplify it or make it more visual and less impactful to the gameplay. How many moving objects? The more objects you have, the more data you send, and it increases exponentially. So you have to be careful about how many objects you want. You don't want to like just throw like 100 players in the same room, and because that'll take up like 30 megabytes and gigabytes per second of data. So what is Among Us about? Let's discuss. Does anyone want to like offer some ideas? Mm-hmm. And feel free to speak up like anytime. Okay. Okay. Mm-hmm. 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 And you also be completing tasks like these. Another one is that you have a lobby that people can connect to. It is very easy to join a game. You just need to enter a code, or you can just go down a lobby list. And then there's also the voting stage where you like try to figure out who's the imposter. There's voice chat and everything. Voice chat I'm not going to talk about because that's kind of separate, but you can also add it. It's also a separate layer that you can add on top fairly easily once you understand like the basics. So here's some ideas that I thought about when I was making this presentation. So the players move around. There are tasks, there's voice chat, lobbies, and it is easy to join games. Using a library. There's a lot on the screen right now, right? And that's usually what like you are met with when you first start networking. There's this 50 choices. They all don't make sense. So let's break it down. And libraries versus frameworks is where I usually draw the line. So libraries, I consider those to be like lower level. They give less for you, and frameworks are more higher level. They give more for you. So analogy that I make is that libraries are a cooking pan, while frameworks are like a kitchen. So libraries are usually one of the tools you have in the kitchen, while frameworks are like the whole kitchen. You have almost everything you need. You might need to go buy like a few groceries here or there. You might need to buy a few tools, few plates and stuff, but you usually have everything you need. So on the left, I have the differences for libraries and frameworks, I have a comparison between libraries and frameworks. For libraries, you have to build your own systems. It's more flexible. It can be used to make any type of game. You have direct access to the data. It is, however, slow to develop with because it's lower level and you have to build everything yourself. Frameworks, it's like a kitchen. It provides almost everything for you. It provides structure. Everything is placed where you need it, and you don't have to figure that out yourself. It is specialized towards making a few types of games. It hides a complex part of networking. However, you still have to understand networking to actually use it. And it is faster to develop with because everything's already made for you. So these are the libraries I showed on the first slide, and then on the spectrum of where they are. So LNL, the blue one on the left, is usually what I program with. It's lower level. I like it, but it's very slow to develop with. And if you're doing that in a game jam, you might be too slow to actually implement anything. It is, however, a good learning experience though. So I recommend it if you want to just play around with networking and not focus on getting a game out. If you do want to get a game out, you want to focus on the right. That's where everything is pre-made. A few warnings though. These frameworks are more engine specific. They're also geared towards making specific types of games. So on the right, I said that they're more general purpose or biased towards FPS type games because those are the type of games that are more people try to make those than other types of games. Most new developers don't try to make an RTS game, for example. And because these are more easy to use, these are more commonly known and there are more tutorials for them. On the left, the lower level libraries, they can be used with any engine or no engine at all. And they focus on just sending data. And you have many options and they're similar in usage. So usually if you want to search for libraries, you would say I would search for C++ networking library. For frameworks, I would say I would search for Unreal networking framework. So with libraries, you search up the program language plus networking library. With frameworks, you want to search engine plus the keyword of framework. So conclusion. So this is often up to preference, as I said, but it heavily affects your development experience. Some games, yeah, they have, it's in the middle of the spectrum, and it's more it provides the tools are somewhat there for you, but it's not as fully fleshed out as the ones on the right provided by third-party Unity developers and Unreal Engine. And I think Random Past in the Discord has took a look at it during one of his game jams. I think it was Global Game Jam. I think. Yeah, Michael K. And some games have to use lower level libraries for additional flexibility. As I said, frameworks are geared towards general purpose or FPS games. So for Among Us, fortunately, it is more of a simple game, so we can use a general purpose framework. So if we use a framework, we'll have faster development time. Among Us consists of simpler mechanics that frameworks already provide, and we don't need to have fine control over the data sent. So network topologies. So this affects how the data is transferred and how players will connect to your game. We'll cover dedicated servers, listen servers, peer-to-peer, and relays. And I included a restaurant example. So what does that mean? So we have servers and clients, right? And you can think of that as servers or waiters in a restaurant and clients or customers in a restaurant. So it will get more clear in the next example. So we have dedicated servers, right? So servers, these are your waiters, waitresses, and every customer will have to talk to them to get what they want. So these servers will be basically managing everything. The server is separate from the game. It's often on a computer that you control. What are the pros of that? It's secure, it is easy to connect to, but it is expensive. So it is secure because it's on a computer that you control. It is easy to connect to for the same reason, but also because you have control over the firewall and all the security settings that you can open the ports and everything. So you also know the IP of the server that you control. The issue is that you need a server. So that usually means that you have to go on AWS or buy a server somewhere, and that's expensive. So some examples of network games that use dedicated servers are Overwatch and Minecraft. And most multiplayer games or multiplayer-only games are dedicated servers. This is something that you might not have heard of, but it is everywhere. So the server is integrated in the game. One player is both the client and the server. So this is kind of like saying in a restaurant, you have a customer, you're now also the waiter. What's the benefit of that? It's cheap because you don't have you're not hiring your own server. You're not hiring a waiter. And that was for single player games because the customer can now serve themselves. It is difficult to connect to because you're relying on a customer to be the server. And the server can be on a private network. They might not want to speak to anyone. Some games that are like this are Minecraft, Unturned, and Terraria. These are all games that you can play in single player, but you can also pretty easily create your own server. Yeah. Oh yeah, I completely forgot to show the images here. So these are how the network topologies usually look. So the lines represent connections, the client represent different players, server is the server and it's orange in the center. So everyone has to cross the server before they can talk to a different client. With listen servers, you have a client host. The client replaces the role of a server. So as you can see, orange has been replaced by the top guy. And now the client is now a client host. It's kind of like a server a waiter customer combo. Usually you could, all the connections are up to you, so you can mangle them however you want. The issue is that if you have two servers, it's hard to figure out who to talk to. Yeah. And the next one is example of that. So peer-to-peer. It is a term that is constantly misused. It can either refer to a web, which is this, or listen servers, which is usually what you want. If you Google peer-to-peer, it will refer more to listen servers than actual peer-to-peer. And it is super confusing for beginners because all popular media will talk about peer-to-peer like it is listen servers. So it's very easy to get confused if you don't know the difference. And because it's a web, this one, it doesn't even show all the connections. So the top client should be connected to that one, that one, that one, that one, that one, that one. So you're missing half of the lines. So because of this, it is super complex because you're managing all the connections, and it's also insecure because everyone's connected to each other, and you can't have someone who's the boss essentially. And relays. This is becoming more popular, and it's the idea of combining both listen servers and dedicated servers together. And this is good because it's cheap, flexible, but it requires a relay server. So the use case for this is that if you have a listen server, but because listen servers are usually behind a firewall on the customer's computer, it's hard to connect. So what you do instead is you put a middleman to relay information from the closed off firewall area to the public internet. So instead of connecting directly to the client host, or in this case the master client, you connect to a relay that talks to the master client for you. And because of this, it's a lot easier to connect. You have the benefit of dedicated servers. The relay is on a computer that you control. But you also have the benefit is that your customer is the server. So it's also cheaper. And the good thing about relays is that relays are also cheap because all relays do is just relay information. They just copy and send the information to different clients. So because of that, it's more general purpose, and you don't need a custom relay server for every game you make. And because of that, Among Us is a relay server. somewhat. So Unturned uses like essentially a matchmaking server or a lobby server, and that keeps track of like all the active like maps that you connect to. Not exactly a relay, because once you're in the game, that you disconnect from the matchmaking server. The matchmaking server is solely for the purpose of matchmaking. Right, yeah. And here's a review of the network topologies. So you take a look, you can see the differences and how the connections are laid out. All right, so conclusions. A server and clients are referred to as assigned roles. That's because a customer can be a server, a client can be a server. And because of this, it's a very important topic to know, because people usually refer to like servers and clients as in like actual separate topics, and that a client can't be a server. But with networking, they simply refer to assigned roles. So like servers, you can have a customer act as a waiter. And it's kind of weird, but it's also how networking works. And key considerations that affect how you do your network topology is cost, security, and ease of use. For a game like Among Us, we'll use a lesson server or a relay server for the following reasons. It's lower cost, and cheating, while unwanted, it's acceptable for a game like Among Us. Like usually you just go to a different lobby or kick that player out, something like that. It's not like a FPS game where you like you like are fighting for like, I don't know, 30 minutes, and you like want to get your next like silver rank or gold rank, and then some cheater messes that up. You get really, really mad, and most players just kind of quit when that happens. And the good thing about relay servers is that usually you can also bundle them with like lobby servers, which are also pretty cheap, and that makes it really easy to connect with players. And there's a tiny little text I put at the bottom. So Among Us actually uses Hazel networking, which is not one of the libraries I put in the original slides, but it's very similar to what I'm talking about today. And there's a link that you can look at after I post the presentation later. So choosing a library conclusion. For a game like Among Us, I would recommend either using Photon Pun 2 or Photon Relay, and these are all Unity frameworks. Or Unity frameworks that have support for Unity Relay. Unity Relay is one of the newer services that Unity provides now, and it can integrate with network code for game objects. And depending on the library, on the framework you choose, some frameworks also have direct support for Unity Relay. And the significance of like Photon Relay and Unity Relay is that they're services. So you don't have to manage the relay server yourself, and that saves you a lot of time, effort, and money. So using the library. So I put the chart back here for reference again, but I won't really talk about it. So we'll now talk about how to like use networking libraries and concepts that apply both to libraries and frameworks, with an emphasis on frameworks. Keep in mind that no framework will provide everything you need. So at some point, you will have to hop over to the lower level side and figure how to do those out. And that's why you need to understand all of the core networking concepts. So state synchronization. This is the core of networking. Every player's game should be the same. When a player moves, they should all be in the right spot. When a player moves, they should always also move in everyone else's game. This is then done by sending message over the network. You can think of this as like playing chess over the phone. So like if you want to move your pawn like 2 spaces forward, you have to go over the phone. It's like, I moved this pawn like at, I don't know, one like A2 or something, 2 spaces forward to whatever that tile is now. And you have to be very specific because there's so many pawns, right? You just can't say, I moved my pawn forward. That's not enough information, right? So of course, the next slide is sending messages. So messages are also called packets, events, or simply data, and exist in different forms. So in frameworks, they might be called RPCs, commands, or events. And in libraries, it might be called byte arrays. Like you can just send a byte array, you can send it as a stream of data, or you can send a discrete packet of information. And you can use these for events or anything that's not automatically synced by the framework. So frameworks will automatically like handle part of the synchronization for you. And these examples, I won't talk too much about them, but the top right one is part of my own code, and that basically tells every client where the player is and what the rotation of the player is. The bottom right is Unreal. The bottom left is Mir networking, which is Unity and how it looks in code. So frameworks, so they will typically provide different ways to like sync data automatically. So look for sync vars, replicate, network rigid body, transform, animator, Unity. So sync vars, you apply that to a variable. The framework will now look at that variable and see when it changes, and if it changes, it will automatically send that information across the network. Replicate is Unreal, and it's basically the same as a sync var. Network, rigid body, transform, animator, these are Unity components that you can see in most Unity frameworks, Unity networking frameworks, and they specifically target the corresponding name. So like if it's a network rigid body, you would have a network rigid body and a rigid body. So the network rigid body will look at the rigid body and like figure out what's happening and send that information across. It's a very good way of like easily like adding drag and drop functionality to your objects, and it's something that you don't. If your game if your game works with it, it's a very easy way to implement it quickly. Otherwise, you have to go through like all the harder steps. The common mistakes. So one of the common mistakes is that people don't realize that every game world is completely separate. They're on separate computers. They're on separate like instances of the program. So you have to send everything yourself, or if you don't send it yourself, it has to be synced by the framework. So the main thing to know about this is that you need to know what the framework syncs for you and what it does not. Because if you make the wrong assumption, something's not going to sync properly. So like, for example, the color of a player is not correct. And I did just say every player's world should be identical. It actually shouldn't. So this is because if every player's world is identical, it might cause issues. So should every single player control the same player character, have the same camera? They shouldn't, right? So player 1 should only control player character 1. So it is important to plan out what data is local to a player and what should be shared. So like a camera should not be shared. It should be local to a player. And it is also a good practice to send enough information for clients to construct everything and to send the bare minimum to do that. The bare minimum means that you only send what you need. And it's good because you usually think about the data better, essentially. You don't just send a gigabyte of information because while that gigabyte might contain what you need, you're sending a lot of noise. And life cycles. So these are things that you probably have seen a lot in normal programming. These are like create, update, destroy. Unity has these as events that these are the first things that you learn in like any engine. And they represent events in an object's life. For networked objects, each of these events must be synced across the network. If you don't sync the create event, the object simply doesn't appear on everyone's game. If you don't sync the update event, the objects don't sync their changes. If you don't sync the destroy event, you might have like ghost objects that don't move anymore, but they're just still there floating somewhere. And those are all bad for a game. And with frameworks usually will handle the lifecycle for you. And it is important to like read up on their documentation on how to do that. So like in Unity, usually you do GameObject.instantiate, but with framework, you might want to look up their docs. They might say you want to use framework.instantiate instead of Unity way of instantiating. And same goes for destroy. You want to do framework.destroy. And some examples of this, as I said, Unity start, update, on destroy methods. So this is an example of lifecycle managed by the engine. These aren't networked by default, but frameworks will often do that for you. Ability started, ended. This is something that's managed by you or the engine. State machines. This is a kind of an extension of life cycles. And it's a more complicated example. So each state has a life cycle. So you might say you started jumping, you ended jumping. So that means that you hit the ground. And you might say started running, ended running. And constructors, deconstructors in the code. This you might have heard of if you programmed. And that's a life cycle managed by the programming language. And there's also a lot more than just this. But the main key points here is that you want to sync the events. And identifiers. Every networked object needs an ID. Like if you're like going back to the chess example, chess over the phone example, you have to be specific about which pawn you're moving. Because if you just say I moved a pawn or I moved an object even, no one's going to know what you're talking about. So it serves as a common reference point. So if you say player 1, we all know what player 1 is. If we say Joe, we all know who Joe is. And it is only partially managed by frameworks. So for Unity frameworks, they usually will will assign IDs for every single network identity, actually for every single game object. But like for assets like images, sprites, textures, shaders, you have to do that yourself. So you have to manage you usually have to manually assign IDs for certain objects, which are usually assets, as I said. And some examples of this, so client 1 has player 1, client 2 has player 2. So 2 ways you can send the message. Player 2 moved from point A to point B. That's enough information for the other client to know what's going on. If you just say it moved from point A to point B, that's not enough. And common mistakes. Each client separately assigning an ID. So one of the problems is that if you assume the local player is player 1, you'll have the situation on the right. Are we both player 1? We shouldn't, right? And it's kind of like a newborn bird, assuming that the first object it sees is its mother. And the solution for that is have a server or a third party tell each client who they are. So like you want a server, as I say, you join first, you'll be player 1. You join second, you'll be player 2. And some common mistakes of this is that if you send a reference or a pointer over the network, that doesn't really work because memory is different. So you have the situation right here. Some random pointer moved to the right. Who is that? I don't know. And if you actually do that in like C++ or something, you just get a seg fault or something. That's bad. And sending a file to both players have over the network is also wasteful because both players already have it. You can refer to that in a different way. So that's like saying player 1 is a map. Insert 5 GB map download here. That's like saying because like if you're in like Tarkov, right? You have like different maps that are gigantic, and each map has like textures, different objects. Like downloading the game already takes a while. You don't want to re-download the map every single time you join the game. So usually you want to say this, we're going to the forest now, and like in each player's game will understand that it refers to the forest scene. So you want to assign. So if the framework doesn't manage it for you, you want to assign IDs manually and use a lookup table. So if you're looking at a red sprite, you'll look up in the dictionary. It'll be like, oh, that's called red. And I'll send red over the network instead of like the actual file. And here's a conclusion for state, life cycles, and IDs. So for a game like Among Us, we'll use network identity components for each player. This will manage IDs and life cycles for us. So these are done. And use unique IDs for different player sprites. That would be like blue, red, and whatever for the sprites. And we won't send images, material shaders over the network if we don't need to. If you do have an exception for this is that if you have like a player profile picture, if you have a way to like set up player's profile picture, the player will have to upload an image to the server. But that's also a more complicated use case that you usually don't see in a game. And you won't sync static parts of the level. So these static parts won't change. There's not really a reason to like say synchronize anything. And for Unity frameworks, you usually want to use the framework to load a scene on every client. So on the server, you'll be like, will go into the scaled map, and every client and the framework will tell every client to load that map. And this is kind of like what kind of data you'll be sending. So player ID 1, bright blue, prefab player, they're in the map scaled. And okay, so a new topic here, authority. So this determines who has control over an object and who is a single source of truth for that object. And it is divided into server authority and client authority. So I make the distinction between authority and ownership here, and that's because a client can own a player character, but because they don't have authority, they can't move it anywhere they want to. And ownership is more of a human concept than a computer concept. So you usually will talk in terms of who has authority to change an object rather than who owns an object. Because your average player, they're not an admin, so they shouldn't be flying around saying that they can do anything in the game. So server authority. So server authority, that means the server has authority over the objects. Only the server can change that object. So it is used when consistency, security, and cheating or cheating is a concern. So the way you do this is that the server treats any actions towards a server-owned object. I guess I used own here, but as a request, not a command. So basically, you'll be like in Among Us. A request would be like saying, "I would like to swing my knife." A command is like, "I swung my knife. Red is now dead." That gives a lot of control to the player. And when a cheater has that much control, they can wreak havoc because they can say, "I swung my knife. Everyone's now dead," and they just instantly win the game. That's bad, right? So commands are used when a client has authority over an object, and if a client does not have authority over an object, they usually have to issue a request. And the main downside of answering requests is that it takes time, which for like certain things, like it will cause latency and input lag. So if you do it for like everything in the game, so if you say like, "I want to move forward," you have to say, "Hey, can I move forward?" The server responds like half a second later, and then you can move. The issue is that you pressed the W button half a second ago. That doesn't really feel that great because you'll be half a second in the past. Half a second in the past is what's being shown on the screen. So that feels really bad for like fast-paced games like FPS games. Like if you want to turn the camera, you have to wait half a second. That's not really great. But on the flip side, turn-based games is where like full server authority is actually very viable even as a smaller developer. Because a turn-based game, you don't really mind if the confirm button takes half a second to respawn. Yes, technically it's the same as like essentially like because with like one connection, two connections, it's like there's not much difference between having a actual like authoritative like assigning a client as a server, because both there's not that many players that would affect. It really depends. And it's actually common for both to either to be used because there's not much difference between the layouts because you're still connecting to each other, right? Yeah, because you don't have a web. Since you don't have a web, it's technically kind of just simplifies down to a listen server. So fully authoritative server. This is an extension of an authoritative server. So the server has authority over everything. And I mean everything. So the server becomes a dictator. So it is used when a security is of utmost importance. So this will be like an Overwatch and other games and other FPS games like Rainbow Six Siege. And I'm not sure about other games, but it can be extremely difficult to implement for everything in the game. So like real-time movement, as I said, the server has to confirm every action the player takes. So if the player wants to move forward, they want to turn around, it has to access the server first, and if you don't have the right code in place to make it feel good, it will be a half-second delay that the player will just see constantly. And players complain even when there's like a 0.2 input delay, 0.2 second input delay. If you double that, it feels bad. So the more realistic way to implement things like movement is client authority. So the client can say that they can move anywhere they want, essentially. You might have some safeguards on the server. So like if the player suddenly moved from point A to like that part to the other side of the room, the server will be like, huh, that looks strange. And that guy gets kicked or marked as a cheater. So you want to use client authority to avoid network latency without needing to like use complex lag compensation algorithms. So common use cases, firing a weapon. If you shoot another player, you want that reaction to be instant. And movement, you also want it to be instant. So for a game like Among Us, we'll prefer server authority because it actually simplifies the code for parts where you don't care about latency. And it's also more resistant to cheating. But we'll use client authority for player movement and actions. So these are the things that might introduce input delay. So like if you press a button, it should respond instantly. So by using client authority, we'll have less latency and less input delay. And a unique application of client authority in Among Us is that we have task and mini games. So these only happen on the client. So you can actually like avoid networking the mini games at all. And that means that the client has authority over everything because the server doesn't even know what's going on. And all the server gets is that the player started a mini game and it ended a mini game, right? Mm-hmm. It really depends on how you implement it because either that they both die or the server catches that one of them already had died, so the second command wouldn't have gone through. But it really just depends on the implementation details. Yeah. And there's a lot of ways you can implement that. If your server is just blindly relaying the messages, both players just might die. And you actually see that in some games like FPS games and stuff, because sometimes if you're like in an FPS game, two players shoot at the same time, roughly at the same time even, the server will be just like, that's a draw. Because if you favor one player and they actually shot at the same time, it would look really bad because it'll feel really bad because they shot like a millisecond earlier and you died for it. Yeah. Yeah, exactly. It works in real life and it makes sense. Kyle Dampier is in the YouTube chat. Say hello. Actually, nope, never mind. Okay. So server client specific logic. So frameworks will often provide values like is server, is owner, and has authority. But with libraries, you usually have to make a distinction yourself. So some use cases for this is that if you're reading input, you only want to do it when is owner is true. If you want to draw a particle effect, you want to make sure that it's on the server. So you only draw it if its server is false. You want to disable a camera if its owner is false, so you don't see the cameras of other players. You send data from one client to the rest of the clients only if its server is true, because the server sometimes acts as a relay. Network reliability. Sometimes a packet of data just goes missing. That's called packet loss. It is kind of like letters getting lost in the mail, and it's usually low around like 1% of the time, which is still decently high. So if you don't have code figuring that out for you, you'll be like, I open the door and the door just never opens on other players, so it'll be kind of weird. And reliable, refers to the guarantee that a packet is always going to arrive. Ordered means that the packet is guaranteed to be processed in the same order as it was sent. But the downside of reliability is that it comes at a cost. Reliability means that if a reliable packet is not received, it will also be resent. That will take time and bandwidth. Missing a reliable ordered packet leads to latency because the packets always have to arrive and they always have to be in the same order. So if you miss one and there's still like others waiting for you to process, your game will be just waiting for that single packet at the head of the line, which is what head of line blocking is. That's kind of like if you're like waiting at a ticket booth, trying to submit in a long line, waiting to like submit a ticket to show your ticket to the person there, and the person at the front of the line lost their ticket, and now they're frantically trying to like find their ticket. They take, I don't know, like the next 5 minutes. Everyone's waiting for that for one person, and it's a problem in games because you don't want to be waiting on everything. An example of this is actually in Minecraft. Minecraft uses only reliable ordered packets, and that means that if you have like a big action like opening a chest, because there's a lot of data involved with opening a chest, everything in the game might just freeze. So that happens fairly often. Like you can just hop onto any server, open a chest full of items, and you might notice in the background that everything freezes, or the chest doesn't open, you have to wait for half a second before everything actually happens. So this goes into sockets and protocols. So these handle handle the previous guarantees of like reliable and ordered. So this is similar to like this is how two computers communicate over the network. For humans, it would be like talking in person, a phone call, an email. Different protocols have different guarantees. TCP is always reliable and ordered, and every packet has to be confirmed. UDP can be unreliable and unordered. And RUDP is an adaptation of UDP to implement what TCP provides, but keep the flexibility of UDP. And these jokes kind of represent how the UDP and TCP work. So TCP, it'll just repeat the joke until you get it, and it will do that forever, or like until they disconnect because they're tired of your nonsense. And I tell you a joke about UDP, but you might not get it. That basically means UDP doesn't care if you get the joke. It'll just move on to the next thing. What's in chat? Base netcode and rollback netcode. Yeah, those are mentioned a lot in fighting games. So I'm going to be talking about those in this presentation, but it's fairly common to like say, I don't know if I should answer this right now because this is kind of like unrelated right now. I do talk about this at the end of the presentation though, as like a sneak peek to like harder challenges in networking. So example use cases of network reliability. These are actually handled by frameworks. I should probably mention that the reliability is handled by frameworks, and you have the option of sending unreliable packets and reliable packets at the same time. So it's usually not a thing that you have to implement yourself with frameworks. Some example use cases is that player position, it can be unreliable, but it also needs to be ordered because you don't want the players like be hopping around. So like it'll be like boom, 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 boom. You don't want it to be like boom, 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 but still end up in the right position. Automatic gun firing. If you're like sending an event per shot, you want it to be unreliable and you want it to be unordered because if your gun is like firing at 60 RPM, or actually not 60 RPS, I guess, you don't really care if like 10 of those get missing. And you also don't notice the order because if one bullet was received in the wrong order, it's really hard to tell, and it's basically impossible to tell. One-time events though, like activating ability, you want that to be reliable and ordered unordered, depending on the circumstances. And reliability means that So for like a player, if they activate an ability, they want it to go through. If you pressed 1 to activate an ability and it doesn't get received by the server, it also feels really bad. So you always want to use reliable sending for one-time events. Player died, it's also an important event that only happens once, so you want it reliable, and the order can depend on your use case. But keep in mind, there's also always exceptions. Okay, this is the deep end that I was talking about. So if your game has physics or anything that relies on state that might differ between clients, it will be hard to develop. If you want your game to be server authoritative while being responsive, it'll also be hard to implement. If you want to have a high number of objects and higher number of players, like maybe 20 something players, that gets to the limit where you have like 20 times 20 data packets being sent. So you have 400 per second or something, and you have to find optimizations at that point. Preventing cheating, that's also something that's really hard. And if you have a smaller game, you should consider like not caring about cheating, or just having a few more like, or even putting in like easier to implement safeguards in there. And I won't talk about the text in black, because those are more like for you to read through if you want to like research these areas, and if those apply to your game. Ryan? Mm-hmm. Mm-hmm. Yeah, that's something that you can consider. I think Minecraft will just send everything that's happening in the chunks around you. But that's related to interest management, to like sync only nearby objects. So you only sync the objects that matter to a player, objects that interest a player. And that happens to like open world games like Minecraft RTSs, where you might be only looking at part of the screen. Hmm. Yeah. 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 And Valorant has like has something similar. If someone's like behind a wall, because you don't want like someone with like beats on to like see the person behind the wall, you just hide them and stop sending data for that player behind the wall. Because otherwise, you can like, there's a player behind that wall there. Let me just intercept them at this choke point or something. Or like even in Rainbow Six Siege, where you can actually shoot through the wall, that would be really, really bad if they can see through the wall. Because you can just like, there's a player that we're dead. That would be really frustrating. So usually those games are very careful about what data they send. And other tips, there's for like a lot of the networking libraries, there are pretty popular discords of like hundreds or thousands of users that also use that framework or library. And it's a good place to like ask questions, because these questions are more specialized, and it's hard to like get these answers in like online or in a more general purpose form. Like even develop, you can ask me, but like if you're using Unreal, I wouldn't have the answer for you. And another tip is that Discord search function is really, really nice, because if it's a common problem, you can search for it, search a few variations of the keywords, and you might just have your problem solved right there and then. And that will save you days and hours of time, maybe even weeks. And other topics, transports. This is related to frameworks and libraries, but I didn't want to include it at the start of the presentation. But this is a way for like frameworks to like use lower level libraries, because frameworks use lower level libraries. It's kind of like changing out the pans in a kitchen. You can use different pans to like cook different types of food. and it's good for like swapping between different protocols and services. So if you're like using RUDP by default, you can then use WebSockets for WebGL or browser-based games. Because the issue of like browsers is that browsers like sandbox everything. It has like very strict requirements, so it only lets you use HTTP or WebSockets. So you're kind of forced to use WebSockets. And if you're using a lower level library and you're restricted to only using RUDP, that means your game can't support browser games. And with Steamworks, Steamworks is kind of like how Photon Relay and Unity Relay work. Steam will help you connect players together and let you access their Steam API to like figure out who a player is and all those kind of things. And that's what Terraria actually uses. So like if you like want to connect to a different player on Steam, you can open up your friends list and just simply connect from there. You don't even have to open the game. So those are kind of like convenience features that you can add to your game depending on what platform you're using. So like if you're using GOG or Epic Games, they have different ways of connecting. GOG I don't think has, but Epic definitely has a bunch of services that you can use. Steam has the same thing. There's also a lot of different services for game-related features. And conclusions. So hopefully this has introduced you like a bunch of common networking concepts and terminology. I didn't cover code, but knowing the concepts will help you research and program without getting stuck. Because a lot of articles, even though they're like beginner targeting, they might assume that you know some of the terminology, and sometimes you might just get stuck on a word. And the good thing about me using more specific terminology is that if you're wondering about a specific concept, you can Google that exact term for more information. Something I want to emphasize again is that networking is all about data. So you want to know what data is sent, not sent, and how it is processed. And also, if you want to ask any other questions, you can ask here, Develop UF, or Develop HQ. Develop HQ. And here's some additional resources. Some of the references I used, which aren't that much actually. And then the end. All right. Anyone have any questions? Brian? You want to answer or? Speaking of, dev hour is going to be in like 50 minutes, 40 minutes. So yeah, 4 p.m. is kind of awkward time though. We might consider changing that. That was based on the when to meet that we sent out a few weeks ago. Yeah. Yeah. And you can see that on the Dev Hour Dev Chatter channel. Yeah. We also have a theme song by Alec. All right, I think I'm gonna stop the stream.